So far in this unit, we've been concentrating on condenser construction and the condensing process. As we noted earlier, in order for steam to condense, latent heat must be removed. This is accomplished by pumping cool circulating water through the condenser tubes to absorb the latent heat in the exhaust steam. The system that supplies this water to the condenser is called the circulating water system. Let's take a look at circulating water systems and discuss their components. This simplified drawing represents a typical circulating water system. This type of system is often referred to as a once-through system because water is returned to its source after flowing through the condenser once. This system is often used where the water source is large, such as a river, a lake, or ocean. And as you can see on this drawing, the system consists of screens, pumps, valves, expansion joints, and piping. Let's follow the flow of circulating water from the water source and through this system. Since the water source can have a lot of trash and debris, there are usually coarse screens and fine screens between the water source and the circulating water pumps to filter out this debris. Coarse screens, often referred to as trash racks, filter out large debris such as logs or branches. Fine screens filter out smaller debris such as litter or trash. Fine screens are often referred to as traveling screens because they rotate into and out of the water when necessary. When these screens are rotated out of the water, they're usually sprayed with water to clean off the debris. After flowing through the screens, the water branches off and flows through the circulating water pumps. Circulating water pumps are generally large centrifugal pumps capable of pumping thousands of gallons of water per minute. Most centrifugal pumps must be completely filled with water or primed in order to operate properly. Priming doesn't pose as much of a problem for pumps that are at or below the level of the water source, but often circulating water pumps are above the water level. For these pumps, a priming system will be provided. So, let's take a minute and talk about one type of priming system. This system consists of a vacuum pump, a priming tank, and a priming valve. The vacuum pump removes air from the priming tank. When air is removed from the priming tank, a vacuum is formed in the tank and in the piping of the priming system. The priming valve is located between the priming tank and each circulating water pump. The function of a priming valve is to open should air enter the pump for any reason. As long as the pump is filled with water, the priming valve remains closed. Returning to our circulating water system drawing, we see that the circulating water flows through the expansion joints and the discharge valves. Expansion joints allow for some piping movement, such as when the pumps are started and a lot of water is flowing through the system. The discharge valve is often a motor-operated butterfly valve. This valve is open while the pump is operating, but is closed when the pump is shut down. This prevents any backflow through a non-operating pump. When the circulating water pump is operating, it adds enough energy to the water to move it through the piping and valves into the condenser, through the condenser tubes, then through the piping and valves that return the water to its source. These components are the water box inlet isolation valves and the water box outlet isolation valves. These isolation valves are often large motor-operated butterfly valves that are open during normal operation. But if one of the water boxes needs to be shut down for maintenance, the isolation valves for that water box are closed, and the water box and tubes can be drained. In this way, the other half of the condenser tubes can continue to operate. These are expansion joints, and as we noted earlier, they allow for some piping movement. The last elements of this circulating water system that we'll talk about are the connections to the water box priming system and the chlorine injection system. The water box priming system is very similar to the pump priming system we discussed earlier. It consists of a vacuum pump, priming tank, and vent valves. The function of the water box priming system is to remove any air in the condenser water boxes. By removing the air from the water boxes, this ensures that the tubes are completely filled with water so that maximum heat transfer takes place in the condenser. The other connection is to the chlorine injection system. The function of a chlorine injection system is to add chlorine to the circulating water, which in turn retards the growth of contaminants such as algae and bacteria in the tubes. Depending on system design, either gaseous chlorine or a liquid chlorine solution may be used. But besides adding chlorine to the system, some plants add other chemicals to reduce buildup of hard scale in the condenser tubes. If these contaminants were allowed to build up, they would reduce the heat transferability of the tubes. As with most of the systems we've been looking at, there can be other designs of circulating water systems. One common variation is this one. This system is similar to the one we just looked at, but for this circulating water system, a circulating water pump serves each water box individually. As you can see, there is also a cross-connect, or tie valve in this system. This valve is closed during most operating conditions. However, one condition that could cause this valve to be open is when one of the circulating water pumps needs to be shut down. With one of the pumps shut down, the discharge valve is closed and the cross-connect valve is opened to allow the flow of water to continue through both halves of the condenser. Under this condition, turbine load may have to be reduced, but the turbine does not have to be shut down. Well, so far we've been looking at once-through circulating water systems that use water from a large water source and return the water to that source.